Hello and welcome to Math Zone African Motives. Today, we're going to dive into the world of algebraic graphs. Specifically, we'll be focusing on a fascinating shape, the ellipse. By the end of this tutorial, you will be able to understand the properties of an ellipse and sketch its graph from an equation. This falls under our Unit 4.2 on algebraic graphs. In this unit, we are going to learn how to sketch the graphs representing various functions and relations. Today's main topic is the ellipse. Before we start sketching, let's establish the key features of the elliptic graph. It's important to understand what makes an ellipse unique. First, the graph is a relation. This means that for at least one x value, there can be two corresponding y values. Next, the graph is continuous. This means you can draw the entire ellipse without lifting your pen. There are no breaks, gaps, or holes in the curve. An ellipse is perfectly symmetrical about both the x-axis and the y-axis. The domain of an ellipse centered at the origin is restricted. The x values exist only between a and plus a. Similarly, the range of the ellipse is also restricted. The y values only exist between b and plus b. Lastly, the graph has no inverse function. This is a direct consequence of it being a relation, not a function. It fails the horizontal line test. Now, let's look at the cornerstone of sketching ellipses, the general form of the equation. The general form of the graph of an ellipse, centered at the origin, is x squared over a squared plus y squared over b squared equals 1. In this equation, a and b are not just random numbers. They have a very specific and crucial geometric meaning. A represents the x-intercepts, and b represents the y-intercepts. They tell us where the ellipse crosses the coordinate axes. To make this clear, let's visualize this with a diagram. Here's the standard diagram for an ellipse. Notice how the variable a corresponds to the points where the ellipse cuts the x-axis, and b corresponds to the points where it cuts the y-axis. This direct relationship between the equation and the intercepts is what makes sketching an ellipse so straightforward once you have the equation in this standard form. So how do we find these intercepts a and b from the equation? Let's delve into the intercepts more closely. From the general form, we note that a squared is under the x squared term, and b squared is under the y squared term. To find the x-intercepts, we look at a. The x-intercepts will be at positive a and negative a. And to find the y-intercepts, we look at b. The y-intercepts will be at positive b and negative b. This means that the elliptical graph will cut the x-axis at the points a and aa. It will also cut the y-axis at the points b and d. Let's repeat that for clarity. The x-intercepts are determined by the square root of the denominator under x squared, and the y-intercepts are determined by the square root of the denominator under y squared. Now that we understand the form and intercepts, let's learn how to apply this to sketch an elliptical graph. We'll follow a simple two-step process. First, we'll examine the general process. Here's a crucial tip to remember when sketching ellipses. Always rewrite the given equation into the general form, which is x squared over a squared plus y squared over b squared equals 1. This step is essential because only after converting to this standard form can you accurately identify a and b to find your intercepts and sketch the graph correctly. Without this, you cannot determine where the ellipse crosses the axes. Let's put this into practice with our first example. Our task is to sketch the graphs represented by the following equations. We will start with the first one. Here's the first equation we need to work with. Remember, our first step is to rewrite it in the general form of an ellipse. X squared over a squared plus y squared over b squared equals 1. This means we need to move the x and y terms to one side, the constant to the other, and make the right side equal to 1. Let's begin by adding 3x squared to both sides of the equation. This will give us 3x squared plus 27y squared minus 27 equals 0. Next, we need to isolate the constant. We do this by adding 27 to both sides. This results in 3x squared plus 27y squared equals 27. We're halfway there. We have the x and y terms on one side and the constant on the other. Now we need to make the right side of the equation equal to 1. To achieve this, we divide every term in the equation by the constant on the right-hand side, which is 27. Dividing gives us x squared over 9 plus y squared over 1 equals 1. This is because 3 divided by 27 simplifies to 1 over 9, and 27 divided by 27 is 1. We are now in the standard form. Let's make the denominators explicit perfect squares. So we have x squared over 3 squared plus y squared over 1 squared equals 1. From this form, we can clearly see that a squared is 9, so a is 3, and b squared is 1, so b is 1. These are our intercepts. Now that we have the intercepts, we can sketch the graph. For the final sketch, we will use the diagram provided. Our equation is x squared over 3 squared plus y squared over 1 squared equals 1. We found that a equals 3 and b equals 1. This means the x-intercepts are at positive and negative 3, and the y-intercepts are at positive and negative 1. To sketch this, you would plot the 4 points, 3 thou, 0.1, and 0.1. Then draw a smooth, continuous curve through these points to form an ellipse. Make sure your sketch is symmetrical. Now let's move on to the second equation and follow the exact same process. The second equation is y squared over 21 minus 1 plus x squared over 49 equals 0. Again, we need to convert it to the general form. The first step is to rearrange the terms so that the x squared and y squared terms are on one side and the constant is on the other. In this case, the constant is negative 1. We can add 1 to both sides to move it to the right, giving us x squared over 49 plus y squared over 21 equals 1. Now we write the denominators as perfect squares to identify a and b. 49 is 7 squared, and 21 is the square root of 21 squared. So our final equation is x squared over 7 squared, plus y squared over the square root of 21 squared equals 1. From this, we can see that a equals 7 and b equals the square root of 21. These are our intercepts. We have the intercepts for our second equation, so we can now sketch the graph. Once again, we'll use the diagram provided for the final sketch. Our equation is x squared over 7 squared plus y squared over the square root of 21 squared equals 1. We found that a equals 7 and b equals the square root of 21. This means the ellipse will cross the x-axis at positive and negative 7, and the y-axis at positive and negative square root of 21. The square root of 21 is approximately 4.583. To sketch this, you would plot the 4 points, 7 thou, 0, square root of 21, and 0 all square root of 21. Then draw a smooth, symmetrical curve through these 4 points to complete the ellipse. Let's quickly compare our results to the memo and summarize what we've learned. For the first problem, we derived the equation x squared over 9 plus y squared over 1 equals 1, which matches the solution in the document perfectly. For the second problem, we derived x squared over 49 plus y squared over 21 equals 1, which also aligns perfectly with the provided solution. So, in this case, the memo's solutions are correct and complete. Today, we have achieved our learning objective. We've seen how to identify the properties of an ellipse, and most importantly, we've learned the two-step process for sketching its graph. Step 1. Always rewrite the equation in the standard form. Step 2. Use the a and b values from the standard form to find the intercepts and sketch the ellipse. This process ensures you can accurately represent any ellipse from its equation. Thank you for watching. Please subscribe for more tutorials from Math Zone African Motives.